Empty space is so familiar, you've stopped noticing how absolutely impossible it should be. Think about it. You're surrounded by nothing right now. The air has gaps. Your body is mostly empty space. The atoms that make you up are 99.9999999% void. And yet that void holds you together. That nothing between your atoms is doing something. If it were truly empty, truly nothing, there would be no force keeping electrons in orbit, no structure, no you. How is emptiness doing work? Here's what's going to frustrate you. The answer destroys everything you thought you knew about nothing. It destroyed what I thought I knew. I spent years calculating what happens at the edge of a black hole, and the answer forced me to accept something that felt like madness. The vacuum is alive, not metaphorically, not poetically, physically, measurably alive with particles that exist and don't exist simultaneously, with energy borrowed from the future and paid back before anyone notices. Let me show you what I mean. The standard explanation of empty space is simple. Remove everything and you get nothing. A void, absence. You probably learned this in school. It's intuitive. It feels right. It's also completely catastrophically wrong. But once you see what's really happening in that emptiness, once you understand what the mathematics demands, you realize that nothing isn't the absence of something. Nothing is the most active something there is. There's something happening in every cubic centimeter of empty space that most people will never learn. Something that connects to why black holes die, why the universe might have come from nothing, and why the cosmological constant, the number that determines the fate of everything, is the most embarrassing miscalculation in the history of physics, all hidden in the nothing between your fingers. Let me take you there. Start with something simple, something you can feel right now. Hold your hand in front of your face. Look at it. Feel the air around it. Now imagine removing that air, pumping it out completely, creating a perfect vacuum around your hand. What's left? Your intuition says nothing, emptiness, the absence of stuff. But your hand would still feel something. Not air pressure, that's gone. Something else, a subtle force, a faint warmth, energy coming from nowhere. Stop and think about that for a second. Where would that energy come from? There's nothing there. You removed everything. Here's what's actually happening. The space around your hand, the empty space, isn't empty. It can't be. The laws of quantum mechanics forbid it. There's a principle called the Heisenberg Uncertainty Principle. You've probably heard the name. But what it actually means is strange beyond comprehension. It says you cannot know both the exact position and exact momentum of a particle at the same time. The more precisely you know one, the less precisely you can know the other. Sounds like a measurement problem, a limitation of our instruments. It's not. It's a statement about reality itself, and it has a consequence that breaks everything you think you know about emptiness. If you cannot precisely know both position and momentum, you also cannot precisely know energy and time. This is the same principle, wearing a different costume. And here's what that means. In any region of space, for any brief enough moment, the energy cannot be precisely zero. The universe cannot commit to exactly nothing for any measurable instant. So what happens? Energy fluctuates. It bubbles. It borrows from the future and pays it back so quickly that no measurement can catch it cheating. These fluctuations aren't abstract. They create particles, real particles, electron-positron pairs, quarks and antiquarks, photons. They flicker into existence for a billionth of a second, then annihilate each other and vanish. We call them virtual particles, not because they're imaginary, because they're too fast to observe directly, but they're there. The mathematics demands it. And here's the thing, we've measured their effects. But wait, if virtual particles are constantly appearing and disappearing everywhere, then empty space isn't empty at all. It's a foam, a seething quantum foam of temporary existence. That raises another question. If this is happening everywhere, all the time, does it actually do anything? Here's where it gets undeniable. In 1948, a Dutch physicist named Hendrik Casimir made a prediction. He said, if the vacuum is truly full of these virtual particles, there should be a measurable consequence. Take two metal plates, put them very close together, nanometers apart, in a perfect vacuum. Remove all air, all particles, everything. According to classical physics, nothing should happen. There's nothing there to push on anything. But Casimir predicted the plates would move toward each other. Why? because between the plates, only some wavelengths of virtual particles can exist, the ones that fit between them. Outside the plates, all wavelengths are possible. This creates an imbalance. More virtual particles pushing from outside than inside. A net force from nothing. This experiment has been done. The Casimir effect is real. It's been measured to extraordinary precision. Two plates in a perfect vacuum with nothing between them are pushed together by the energy of emptiness. The void exerts pressure. That should break your brain. The vacuum, literal nothing, has measurable physical force. But that's still not the full story, because if the vacuum has energy, how much energy? Now we're at the core. When physicists calculate how much energy the vacuum should contain using quantum field theory, our most successful scientific theory ever, they get a number. That number is approximately 10 to the power of 113 joules per cubic meter. For context, all the matter in the observable universe contains about 10 to the power of 70 joules. The vacuum energy, according to our best calculations, exceeds the energy of all visible matter by a factor of 10 to the 43rd power. 10 trillion times more energy in nothing. I'll be honest with you, this is embarrassing. This is the largest discrepancy between theory and observation in the history of science. It's called the cosmological constant problem, and nobody knows how to solve it. But here's what we do know. The vacuum is not empty. It cannot be empty. The only question is how much energy it contains, and we've clearly made a mistake somewhere in our calculations. The nothing is full. The only question is how full. In your normal experience of the world, emptiness is simple. A void is an absence. Nothing is nothing. You trust this. You've built your entire understanding of reality on it. Solid things have energy. Empty spaces don't, except that's completely backwards. The nothing between atoms contains more energy than all the matter in the observable universe combined. Let me prove it to you. The Casimir effect, measured, confirmed, published in Physical Review, plates pushed together by the pressure of emptiness, Lamb shift. The energy levels of hydrogen atoms are shifted slightly from classical predictions because the electron interacts with virtual particles in the empty space around it. Measured to 11 decimal places, Hawking radiation, my own contribution. Virtual particle pairs can form at the edge of a black hole. One falls in, one escapes. The black hole loses mass. It evaporates. Black holes die because of particles that come from nothing. This isn't speculation. This is measured. This is tested. This is the actual structure of reality. Think about what this means. You've never experienced true emptiness. Neither has the universe. Every void you've ever seen, between stars, between atoms, between your fingers, is churning with activity. The space inside your body, the 99.9999999% of you that's empty, is the most energetic thing there is. You are not mostly nothing. You are mostly everything, temporarily pretending to be calm. The nothing between atoms contains more energy than all the matter in the observable universe combined. I know that's uncomfortable. Good, it should be. The universe doesn't owe you a comfortable answer. It owes you the truth, and the truth is that nothingness doesn't exist. Now here's what people miss when they learn just about the quantum vacuum. They think it's a curiosity, a quirk of quantum mechanics. It's not. It's connected to everything. The same quantum fluctuations that create virtual particles seeded the galaxies. In the first fraction of a second after the Big Bang, quantum fluctuations were stretched to cosmic size. Those tiny ripples in nothing became the density variations that grew into every galaxy, star, and planet. May have created the universe itself. Some physicists believe the entire cosmos emerged from a quantum fluctuation in the vacuum, something from nothing, existence borrowed from non-existence. Drive dark energy. The accelerating expansion of the universe may be caused by vacuum energy, the same energy we can't calculate correctly. Kill black holes. Hawking radiation drains mass from black holes over eons. The void slowly devours the most powerful objects in the universe. What looks like many different phenomena, galaxy formation, cosmic expansion, black hole evaporation, is actually one thing manifesting in different ways. The quantum vacuum expressing itself. You're not separate from this. Right now, virtual particles are flickering in and out of existence inside your atoms. The vacuum energy is part of your structure. You're held together by the same seething emptiness that created galaxies and kills black holes. That's not mysterious. That's not distant or abstract. That's magnificent. That's what reality actually is. And you've been swimming through it your entire life without knowing. So, what is empty space? It's not empty. It's not void. It's not nothing. It's the ground state of all quantum fields, electron fields, quark fields, photon fields, vibrating at their minimum possible energy. And that minimum isn't zero. It can't be zero. The uncertainty principle forbids it. What you call nothing is actually everything at its lowest setting, still humming, still fluctuating, still creating and destroying particles faster than time itself can measure. But understanding this isn't just about vacuum physics. It's about what we can know, what we can figure out. 100 years ago, we didn't understand any of this. The quantum vacuum was invisible, unmeasured, undreamed. Then we built the mathematics. We made predictions. We tested them, and the universe answered. The Casimir force, measurable, the Lamb shift, calculable, Hawking radiation, derivable, the fact that we can peer into nothing and find something, the fact that the void confesses its secrets when we ask the right questions. That's not trivial. That's the greatest triumph of human intelligence. We looked into emptiness and found infinity. That's what empty space really is. Not absence, not void, not nothing. A seething ocean of potential, barely contained, vibrating at the edge of becoming everything. Not comfort, not simplicity, truth. If this journey into the quantum vacuum changed how you see the space around you, subscribe and share it with someone who still thinks emptiness is simple. What other obvious things do you think hide this kind of depth? What else have we stopped questioning? Tell me in the comments. The void is listening.